So this is going to be a short video on a mock test for Mr. Rakesh. So ready to go?
Yeah.
Okay, your voice got slightly low. So if you just get the mic slightly closer.
Actually, my Bluetooth is not
Okay,
has
no
a
issues.
power.
I'll fix that later. So the first question is going to be tell me
Okay.
about yourself.
Okay. First of all, thank you for giving me this opportunity to introduce myself. My name is Rakesh, and I am from Jammu and Kashmir, the state city Jammu. So I have done my 10th and 12th from a state board itself with 82.2% and 69.4% in PCM. So I have done my BTech in mechanical engineering from Coimbatore Institute of Technology under the Prime Minister's Special Scholarship Scheme. So I have a good interest in listening podcast and cooking. So talking about my achievements, I have a NCCB certificate, and I was the sports captain in my college, like a volleyball team. That's
Okay.
all about myself.
So what I'll do is I'll also make notes for each question so that you can later find out, how to better improve on that.
Yeah. Okay. Yeah. Okay.
Okay. So next question is going to be tell me about your strengths and weaknesses.
So my biggest strength is, as I told you, that I was in NCC. So I know how to be deal with the different nationalities because I have selected for the national camps. So I know how to deal with the people from different nationality, and in NCC they mostly teach us about the discipline life. So this is my strength. Like I am very disciplined and obedient guy. And about the weakness is currently, as you see, my communication is not very up to marks. So currently, I am working on it by giving some mock interviews and daily practicing in front of mirror.
Okay. So what really motivated you to come into this specific field?
Okay. So during my college time, like I wanted to do something different from it. It's like everyone is going in a design or some production things. So at that time, a college senior, he came to our college for some seminar. Basically, he is a second engineer now. He told us about the exposure and the responsibilities that we get at a very young age on this field. That how we have to work with the pressure, how we have to handle the work pressure, how we have to meet with the people from different nationality. That inspires me a lot to join this field. And after all research, I know this is the best field suited for my profession. That my uh, achievements that I got in this field.
Okay. So currently you said that you had started your BTech. Have you completed that?
Yeah, I have completed it in 2021 in May.
Okay. So what are you currently doing?
2022. Sorry, pardon me.
So what are you currently doing since then?
Currently, I am working in a company called Sterlite. Basically,
Okay.
it is a telecommunication company. So my uh, role in that company is I have a team of 6 members, and sometimes it gone up to 12 members. So I have to manage the people according to the work. I have to give them the work and report to the authorities about the work.
Okay. So the next questions now will be the technical. Okay, so if you have any paper or something nearby.
Yes, I have.
Okay, so give me the valve timing diagram of four-stroke diesel engine.
Okay.
So 4-stroke diesel engine,
Yeah.
valve timing diagram. Okay, so go ahead and explain it also.
Okay. So at starting from when piston comes down at 20 degree before the piston reaches TDC, the piston comes down. So in this, inlet valve open and the air starts coming into the combustion chamber. So till the piston reaches after 35 degree of BDC, the piston inlet valve closed, so that this 35 degree is there because we have to add the more amount of fresh charge into the cylinder. So after that expansion start, and 20 degree before the piston reaches TDC, the fuel valve open and the fuel start injecting into the combustion chamber.
Okay.
So it till the time it piston reaches TDC, the fuel is going added into that, and it is still some fuel is going on into the combustion chamber after TDC for 15 degree, so that we can burn more amount of fuel. So once it reaches to the TDC, the fuel that injection fuel starts burning take place due to the high compression, and expansion start after when the piston starts moving down, the expansion starts, and around 35 degree before the piston reaches to BDC, the exhaust valve opens. Okay, and after piston reaches to TDC, and after 35 degree piston reaches to TDC, the exhaust valve closes. There is some part of into that 25 degree, that is valve overlapping.
Okay, so why do we need valve overlap?
Valve overlapping is provided just to ensure that no burnt gases is still in the combustion chamber, so that all the burnt gases has to be removed out, so
Okay.
that we for the cycle we can burn more amount of fuel.
Okay, so explain the rocker arm assembly.
So a rocker arm is basically a lever that transfers the motion from the push rod to the valve stems. It is basically helps in for opening and closing of the valves.
Okay, and how's the working?
So like when one end is raised in that, so when the push rod pushes that, it is like this. So when the push rod pushes the rocker arm from one end, it has a that pressure on another side that helps in opening and closing of the valves.
Okay.
Sorry.
So explain a marine 2-stroke diesel engine with parts.
Okay, marine 2-stroke diesel engine. So starting from the top, we have the cylinder, that we have the cylinder bore. We call it a cylinder top. On that, the fuel valve is there. Okay, then a cylinder liner is there. Then piston rod is there. Then we have the crosshead bearing is there. Then a connecting rod is there. Then crankcase, crank web is there. Then we have the casing over there. In that, we have with the connecting rod, we have the flywheel is connected with that. Yeah. That's
Okay.
all the part.
That's all. Okay, fine. Explain TBN.
TBN. So it is basically the total base number. So when we burn the fuel, that low grade fuel, it has some sulfur content in that. So to neutralize that, we need some base in that. So that's why we choose the TBN of high or low petrol, diesel or oil.
Okay, so in terms of two-stroke lubrication, where will you use high TBN, low TBN? How is it?
So in terms of two-stroke in cylinder oil, we use the higher TBN because in combustion chamber, when we burn the fuel, it produces the more amount of that gases that harms to the combustion chamber. So for that, we need a high TBN value that may uh, compensate the that sulfuric acid or like so that the corrosion does not happen.
Okay. And then lower one will be at the bottom side.
Yeah, that is a some oil.
Okay.
The higher TBN value is 70 and the lower one is around 30 or 30 something.
Okay. Explain the exhaust gas turbocharger.
So basically, turbocharger is a device which is used to charge the fresh air for pressurizing air and for increasing the density so that we can burn more amount of fuel to get the more power. So the proper functioning is like when the exhaust gases of coming out from the exhaust valve, it has to be stored in the exhaust gases manifold. So the gases coming out from the exhaust gas manifold has sent through the turbine. As the turbine rotates, it rotates the shaft. Due to with the help of the shaft, the blower starts rotate and it sucks the air, which increases the pressure but it increases the temperature also. With that, the density of the charge will decrease, which decreases.
Okay.
So after passing through that, we have to pass it through the air cooler so that the density of that charge increases because we need more density in that. So that's why we use the turbocharger.
Okay. So explain a bursting disc.
So a bursting disc is basically a copper disc which is used as a safety device in the air compressor. So when the like so when air comes out, when if there is any leakage in the, it is basically provided in the intercooler and the aftercooler.
Okay.
So if any case if there is any leakage over there, the pressurized gas comes out from that pipes which is in the intercooler and it pressurizes the water, which with increase in the pressure of the water, the bursting disc burst and it all releases the water. With that, our pressure decreases. So
Okay.
it is used as a safety device in that.
Why should we never run a positive displacement pump with the discharge valve shut?
Oh, so it is basically like sorry, pardon me, can you please repeat the question?
Yeah. Why should we never run a positive displacement pump with the discharge valve shut?
So as we see that the positive displacement pumps names itself say that it positively displaces the fluid. So if in case our discharge valve is shut over there, the positive displacement pump keeps running on and it start sending the water. So with that, our chances of busting pressure starts increases over there. Due to that, chances of busting of pipes and impellers pumps is there. So that's why we have to keep it open.
Okay. How does centrifugal pump generate pressure?
So as we know that the pump is a work-consuming device, so with the help of the motor, which starts rotating the impeller. As the impeller rotates, so it imparts a centrifugal force to the water, and when the water comes out from the centrifuge of the impeller, it enters into the guide vanes. As we see that when the out Okay, so at the end of the impeller, it has a high connector. The water has a high kinetic energy, but according to, as we see that the volute casing of the centrifugal pump is keeps on increases. So when the water goes into the higher discharge, into the higher volume, that high volume, its pressure start decreases over there. Its kinetic energy starts decreases over there. According to the continuity equations, if area of the cross section starts increases, that velocity starts decreases over there.
Yeah.
So when the velocity starts decreases, that means its kinetic energy of the water is decreases. So by the law of conservation of energy, the moment the kinetic energy starts decreases, the pressure energy starts increases over there. So this is how the pressure is created at the discharge side in the centrifugal pump.
Okay. So now differentiate between rotodynamic and positive displacement pump with terms to what will happen to the efficiency based on different values of flow. So flow of the pump is there. Changing the value of flow, what happens with the pump efficiency in rotodynamic and positive displacement?
Okay, in starting from that rotodynamic pump, in rotodynamic, it is basically of two types: centrifugal pump and axial flow pumps. And in positive displacement pump, it is further classified into the rotary type and the reciprocating types. So in rotodynamic pumps, basically when the load increases, as the load increases, as the flow increases, the load start increases over there. And talking about the efficiency, so efficiency start decreases when the our flow starts increases over there in the rotodynamic pump, and efficiency remains constant in the positive displacement pump. Rotodynamic pumps are basically used where we need high discharge, not a very high pressure is required. But positive displacement pumps are basically used in the where we need very high pressure, for transferring the fluid to the for transferring the fluid, we uses the gear pumps. So it is a
Okay,
type of
so coming back to the efficiency of rotodynamic or centrifugal pump, you said flow is higher than what happens to efficiency?
efficiency start decreases
Okay.
in centrifugal.
Okay.
Yeah. So in centrifugal pump or in a rotodynamic pump, we keep discharge valve shut while starting the pump. But in case of rotodynamic pump, we can't do that. In rotodynamic pump, we use the priming over there for centrifugal pump, and that in rotodynamic pumps are basically used as a on ship rotodynamic pumps are used as a main engine pump, main engine seawater pump, main engine lube oil pump. And in rotodynamic, that positive displacement pumps it is like for transferring the fluid, for transferring the sludge, we are using that gear pumps and the screw pumps.
Okay. So explain the full VCRS cycle.
Okay. So VCRS cycle first mainly consists of 4 parts. That first is compressor, condenser, that thermostatic expansion valve, and the evaporator. So starting from the compressor, when the vapors of the refrigerant comes into the compressor, the function of the compressor is to compress and to increase the pressure rise and to increase the pressure of the refrigerant. So as it increases the pressure, that its temperature starts increases over there, and the vaporized pressure is converted into the gas form. So then this
So
gas
vapor and gas is the same.
Yeah, but it is some droplet. No, yeah.
Okay.
Okay. Then this gas refrigerant has to pass through the condenser, where with the help of the seawater pump, its pressure remains constant, and but the phase changes over there, that the gas refrigerant is converted into the liquid refrigerant. Then this refrigerant has to pass through the dryer, where if there is any moisture content in with the help of the silica gel, it extract all the moisture. Sorry. Then this refrigerant has to pass through the thermostatic expansion valve. This thermostatic expansion valve is like an orifice. When this refrigerant has passes from this orifice, that suddenly the its pressure start decreases over there in the thermostatic expansion valve, and the pressure, somewhat pressure, is also decreases over there. So with the with the moderate pressure, with the very low pressure, and some part of the that liquid refrigerant is converted into the gas part, into the gases form. So then this liquid refrigerant has to pass through the evaporator. So with the meat room and the fish room, it extract the heat from the refrigerant, and it converted into the gases or the vapor form. This then this refrigerant passes from the sensing bulb. This sensing bulb senses the refrigerant and tells us how the refrigerant is like. How the superheat of the refrigerant is there. If it is more, it sends a signal to the thermostatic expansion valve through capillary, so to send the more liquid, so that the degree of superheat always maintains, and it that liquid refrigerant does not go into the compressor, because it decreases the efficiency of the compressor.
Yeah, and will damage it also.
Yeah.
So, do you know the value of the refrigerant within the evaporator temperature value?
So basically, it depends upon the type of the refrigerant we are using. So like for currently we are using the R134A. So for that, it is depends upon, for meat room it is minus 18 degree to minus 20 degrees Celsius, and for a veg room it is 5 degree to 8 degrees Celsius.
Okay. So you mentioned one of them, which is that R143A. Any other refrigerants used?
404A, R417,
Okay.
R600.
So give me the boiler mountings and their uses.
Boiler mountings. So boiler mountings are like there is a first one is a steam stop valve, then a blow down valve is there, then scum valve is there, then a feed check valve, water level gauge glass, safety valves are there, then there is a fusible plug is over there, a steam stop valve is there. Yeah, that's all I know.
Yeah. So explain the use of each one.
For safety valve, we have the two safety valves, because if any case our pressurized goes more than the safety limit, it increases, it starts lifting up and releases all the pressure. There are two safety valves, because if any of one is not working, so the other one lift up and releases the pressure. So the difference in both that relief valve values is 0.5 bar. And about the feed check valve is just basically use. Sorry, first I can tell you the water level gauge glass.
Okay.
There are two water level gauge glasses over there. So if our water level in the steam drum it start decreases, so we can get the value from that water level gauge glass, the how much the water is present inside the our steam drum. So if it is less, so with the help of the feed check valve, we can just fill the requirement of the water in the steam drum. So there are two feed check valves in the this in in this boiler, because if any of one is like a non-return one, and one is like I am not able to recall the another one name. So if like our non-return valve is not working properly, so with the help of the hand, we just turn off the another valve, and we can later maintain it.
Okay.
With the help of the steam stop valve, if like it is generally used to stop the steam hammering. So and talking about the blow down valve, it is basically provided in the lower side of the water drum. So when the if water gets contaminated, like if there is any impurities in that, So by opening just the blow down valve, we can remove all the water from that, so that there is no corrosion or something like that. And talking about the scum valve, and a scum valve is basically used. We know that not all the impurities get that settle down in the water dump. So some of them are like just floating on the top above. So by with the help of the scum valve, we can just remove that impurities. And steam pressure gauge is there, like it is generally used to check the steam pressure, that how much the pressure it is that our boiler is producing. Like if it is less, so there is a chance of explosion and implosion is there. So yeah, I think that's enough. That's all I know.
Okay, so which one will be used in terms of to avoid implosion?
Sorry, pardon.
No, so which of the boiler mountings will help to avoid boiler implosion? IM.
Steam stop that steam pressure gauge.
No. So implosion means the boiler is going to get crushed. So how will the pressure gauge stop that?
No, sorry, I don't know about that.
So that can be the air vent.
Oh, okay, yeah, yes. Sorry.
Okay, so differentiate.
Just repeat.
Sure. You're done.
Yeah.
Okay. Differentiate between water hammering and steam hammering. Explain the two.
So steam hammering is basically a phenomenon like when we open the steam valve in a very rapid way. So basically, sometimes the steam comes in contact with the water that is it is in the condensed form, like steam in the condensed form. With that, suddenly the pressure drops. With that, there is a chances of that implosion or explosion is there. Like a very bad sound comes into that. So it might.
So where's the explosion going to take place?
Like not like the explosion, like it is producing a bad sound that might not be there.
Inside the boiler or where?
Inside the boiler.
Okay, and water hammering?
Water hammering is like the same, just like the same. Like in this, when we open the valve, like sometimes when we open the valve, like just we completely open up the valve. That same in the case that might get. Actually, I am not very sure of it, so I'm not able to.
Okay. So explain a three-phase induction motor.
Okay, so three-phase induction motors are basically used in a large-scale industry. It is basically produced. It is a very commercial use one. Like so, talking about it is basically consists of the stator and the rotor. The stator is stator winding is there. Then stator winding, the stator core, stator frame is there, and rotor is of rotor. I'm not able to recall. So when working is like that, when we give the three phases of AC supply to the stator winding, it produces the rotating magnetic field inside the stator. So as we put the rotor into that. So as we put the rotor into that, the rotor cuts the rotating magnetic field inside the stator, and the current start produces into the rotator, which helps in which starts due to which the magnetic fields the creation of magnetic field is inside the rotor. So which is basically the same. So as our it is not sorry, pardon, I am not able to.
Okay, that's fine. Tell me, what is viscosity index?
So viscosity index is like when we go on from one region to another region, there is a change in temperature, or there is a change in condition. So a viscosity index tells us if the viscosity is affected too much with increase in the temperature. that it means that it has a low viscosity index. So if it does not changes with the change in the temperature, that it does not affect with the change in the temperature, that it has the high viscosity index.
Okay, so that's the end of the mock exam. I made a few small points. I'll share that with you so that you can improve on that. Thanks.
Yeah.